Hello everyone, this is the third part of the series Learn about Arduino and Programming. If you haven't watched the previous videos, please do check it out. The link to the playlist is available in the description box or you can find it in the I button on the top right corner of your device. In this tutorial, we will be learning to use the breadboard and its internal connections, LED on the breadboard, push button and 7-segment display on the breadboard. I am Kaver, you're watching Tech Domicile. Without further ado, let's get started. This is what the breadboard looks like. Breadboard is a device for holding the components of a circuit and connecting them together. It is commonly used to build electronic circuit without doing any soldering. The top two rails and bottom two rails are called power rails. The top row of holes are connected together and are marked here with red dots and blue dots. Note that the connection breaks in the middle of the breadboard. In the middle, the column of wires are connected together. For example, all the green holes marked are connected together but they are not connected to the yellow holes. LED. LED stands for light emitting diode. It emits a colored light when there is a current flowing through it. An LED has two leads, namely anode and cathode. The longer lead is the anode. It should be connected to the positive voltage. The shorter lead is the cathode. It should be connected to the ground. Tricolor LED is an advanced version of LED which emits 3 different colors. It has 4 pins. The longest lead is called the common lead. The remaining 3 pins are for the red, green and blue color LEDs. There are 2 types of tricolor LEDs, common anode, common cathode. In common anode version, the common lead should be connected to the positive voltage. In the common cathode version, the common lead should be connected to the ground. Resistor. Resistor is an electrical component that limits the flow of current in an electronic circuit. Now, let's build a simple circuit using a LED, a resistor and a breadboard. The image shows the proper connections. Note that here I am using my power supply. If you don't have, you can use any 9-volt battery. The positive of the power supply is connected to the second rail. Negative is connected to the first rail. Anode, that is the right lead of the LED, is connected to the second rail of the breadboard through a resistor. Cathode, that is the left lead of the LED, is connected to the first rail of the breadboard. This is the live setup of the LED connections. We can see that the LED is glowing because the connections used are proper. Now we will see the common mistakes people make while using a breadboard. In this connection, the LED doesn't glow because the connections are not proper. The resistor and LED are placed beside each other. The holes in the breadboard except the power rails are connected column-wise. So, there is no connection between the anode of the LED and the resistor lead. This makes the LED isolated. In the next connection, the cathode of the LED is connected to the second rail. The anode of the LED is connected to the first rail through the resistor. The connection in the circuit are the reverse of what it should be. That's why the LED doesn't glow. The push button. A push button is a simple switch mechanism that connects 2 points in a circuit when pressed. Push button usually comes with 4 legs. Irrespective of the position of the switch, legs A and C are always connected. Similarly, legs B and D are always connected. When the switch is pressed, all the 4 legs are connected to each other. Now, let us add a push button to the previous circuit and use it to change the state of the LED. The image shows the proper connections. The LED anode is connected to the second power rail, that is the positive voltage through a resistor and a push button. Let's see the live setup connection. When the push button is pressed, the LED glows as expected. As there are 4 legs in the push button, the circuit can be built in another way as well. Instead of using the leg B of the push button, we are using the leg D. Since they are internally connected to each other, the LED glows when the push button is pressed. Now, we will see the common mistakes people make while using a push button. Look at this image. The anode of the LED is connected to the second power rail through legs A and C of the push button. Recall that the image A and C of the push button are internally connected. Hence, the anode of the LED is always connected to the second power rail, irrespective of the push button. The LED always glows in the circuit even when the push button is off. The 7-segment display. The 7-segment display has 7 LEDs arranged in the shape of the number 8. There are 2 types of 7-segment displays: common anode, common cathode. In a common cathode, pins A, B, C, D, E, F, G and dot must be connected to the positive 5 volts. The 2 common pins must be connected to the ground. The common anode display is exact opposite. Here, pins A, B, C, D, E, F, G and dot must be connected to the ground, and the 2 common pins must be connected to plus 5 volts. Now, let's see how to connect a 7-segment display on the breadboard and glow all the LEDs. The 7-segment display used here is a common anode. So, the common anode is connected to the second power rail through a resistor. LED pins A, B, C, D, E, F, G dot are connected to the first power rail. If the connection is proper, we will see that all the LEDs are glowing. Let's see the live connection setup. We can see all the segments in the display is glowing.
This brings us to the end of today's tutorial.
So, that's it for today. If you like this video, give a thumbs up, and if interested in this series, please subscribe the channel and stay tuned. If you have any queries, feel free to comment. You can also follow me on Instagram at TechDomicile. Thanks for watching.